Hello, good morning.
Good morning to one and all present here. Good morning to one and all present here. I, Tidik Shiny, 5th sem student, Electrical and Electronics Department SSTC, welcome you all to day 2 of ATAL FDP on application of Internet of Things in Environment, Medical Science and Human Life, organized by Department of Electrical and Electronics Engineering. So the topic for first session is potential IoT applications like smart health, smart home, etc. by Dr. Debanjan Das. Dr. Debanjan Sir is an assistant professor in electronics and communication engineering of IIT Naya Raipur, Chhattisgarh. He has completed his MTech and PhD from the Department of Electrical Engineering, IIT Kharagpur, in the area of sensor and instrumentation. Currently, he is the faculty in charge of IoT and Sensors Lab in IIT Naya Raipur. Along with this, he is holding different responsible posts like PhD faculty coordinator, member of Institute's research consultancy, and academic planning committee, etc. Dr. Das has more than 8 years of research and development experience in the session and instrumentation, signal processing, etc. He has published about 40 research papers in international journals and conferences, including prestigious publication in Nature, IEEE. Currently, his main research interests include IoT and smart sensing, medical IoT, agriculture IoT, signal processing, and biomedical engineering. He is senior member of IEEE and IEEE Engineering Medical Biology Society. We welcome you, sir. I request you to please bless us all with your precious words. Please, sir.
Okay. Thank you for your nice introduction. So, at first, very good morning to all of you. I'll share my screen and I'll start my the talk. Okay, but before that, I want to thank the organizing committee. Okay, to invite me and to arrange a section on this area, like the where the role of IoT in our um, different use cases. Like he has mentioned that the session is on the human healthcare, the environment, or many other cases, right? But I have selected the topics on the role of IoT on the healthcare domain. Okay, so who is sometimes we also called IOMT, Internet of Medical Thing. Okay, so I'll just give a talk on that. So my talk, you'll understand that it will be yes some things in general point of view, and then we'll more emphasize on the research point of view. Okay, means whatever the work that we are doing in our group in IIIT Naya Raipur. Right, so some of the examples I'll show from there, and along with I'll also try to highlight what are the research opportunity or the challenges it still exist. So hope that will help uh, in general all the audience to those who are working or interested to work in this area, right? Like the smart healthcare using these IoT AI these techniques, right? So you will get some idea, or it will enrich your knowledge on that domain. Okay, so with this I'll just share my screen, but before that, to for better signal strength, I just switch up my camera. Okay, uh, let me share my screen. Okay, so hope my screen is visible.
Yes, sir.
Yes,
Screen is
okay.
visible.
uh, so the title, as you can see here, that the title I kept IOMT, a smart healthcare paradigm. Okay, so we'll see what is this IOMT, what is this smart healthcare, right? With the certain examples, right? If you want to make a IOMT solution, how can you make it? What are the constant that what are the points that you have to keep in mind while developing that. Okay, so I'll discuss all those things step by steps, but before that, the one thing I'll request all of you, if you have any queries, please unmute and ask the questions. Okay, because as I am in the full screen slide mode, I may not able to visualize your chat question. Okay, so in between, if you have any question, please uh, don't hesitate to the ask. Okay, for that, better you unmute and ask the question. Okay, so the outline of my presentation. Okay, so it is that it will see that how the healthcare it moves from that traditional to the smart healthcares. Okay, then we'll also see what is this smart healthcare, its characteristics, then what are the components of these smart healthcares, then the examples under these smart healthcares means under this IOMT. Okay, then in parallel, I'll also talk certain technology, okay, which is used in this smart healthcare paradigm. Right? Then what are the challenges that still it exists, or the research problems we can easily formulate keeping those challenges. And finally, I just conclude with the direction of the future scopes. Okay, so these all those things that we are going to discuss, and through this, what I want to say that at the end of our session, okay, I will expect that you people will get an idea that the what is this smart healthcare and what is the role of IoT and AI, okay, on that domain, right? So first and foremost things, if you see the traditional healthcare, right, all of us we are familiar with this. Okay, so where you'll find in traditional healthcares the that you have a physical presence is needed, right? Means you have to visit the respective hospital or diagnostic center. Okay, the physical presence is needed. Okay, in traditional healthcare point of view, I'm talking. Okay, although in this last 2 years, okay, many things has changed. Okay, after these pandemic situations. Okay, so actually this we'll also see this pandemics also is enabling us to develop more research on these smart healthcares. Okay, so the healthcare industry, healthcare research verticals is also getting day by day more advantageous or more advancement. Okay, so on that context, if, whatever the things that you can see in the traditional healthcares, like it deals with the many stakeholders, means where your patient is there, doctors is there, pharmacist, right, your pathologist, right, many stakeholders are involved. Okay, but unfortunately, those stakeholders, they are not able to communicate to each others in traditional healthcare point of view. Okay, next, the healthcare facility, okay, so it may not be personalized. Okay, and not much active feedback is presence. Okay, and further no follow up from the physician. Okay, you have to the follow up. Okay, so these are the you can see the certain characteristics. Okay, those characteristics may have certain advantage, certain disadvantage, or the limitation. Okay, so those limitations is actually is overcome through this the latest the introduction of this IoT, artificial intelligence or machine learning, and then together to build up these smart healthcares. Okay, so in gist, if you see that if you see the traditional healthcares, okay, so this traditional healthcare facility is a resource constant. Okay, means it requires lots of resource because the patient need to come. Okay, required that the well infrastructures, right? The places, that many capacity, right? That many number of doctors, nurses, right? So it requires the use the resources. Okay, so that means on that content, you can say, right? The resource constant is one of the things. Okay, and it is a hospital centric and reactive in natures. Means reactive means if you have some things, okay, already you have some problem, then only uh, that you will take you will get the cares. Okay, but it is the now it is coming that it need to be active in natures. Okay, means before the things happen, right? It should actively take care that situations. Okay, so that's is that actually the motivation. Okay, with that motivation is actually that certain different other technology, it is drastically changes this smart healthcares or healthcare paradigm. Okay, so the first is the telemedicine, right? So now this we are all of us are familiar or quite many of are quite very often using this facility like the telemedicine or the teleconsultation, right? So which actually use this telecommunication and information technology to provide the clinical healthcare for from a distance. Okay, so this telemedicine is not only for the consultancy purpose. Okay, so this telemedicine is also used for surgery, that or telesurgery or many other applications. Okay, um, mainly you will find this before the pandemic also these telemedicine telehealthcare facilities there in contrast to the rural healthcares. Okay, or for example if you take the situation in northeast side of our India. Okay, so where in the remote locations, right, the doctors or the sufficient doctors are not present, right, or the facility is not present, right, so they generally come in a centralized place and then from there um, the one of the main center who takes care the facility, right, so they do this check up and follow up through this teleconsultation or the telemedicine. Okay, those kind of things is theirs. Okay, but now this pandemic is actually boosted this telemedicine or the teleconsultation facility. Okay. Now on the next this we can also see this electronic healthcare card. Okay, because if you visit any hospital scenario, right, so you'll find this EHR. Okay, electronic health record is one of the very common things. Okay, so that is also part of these healthcare facilities. Okay, because they are all of your histories maintained. Okay, and daily means regular basis when the follow-up visit you are doing, right, so then you can see that what is the progress. Okay, what the last time medication is given, what is the effect of medication, whether the it is working perfect or need to change some things, right, all the health related the records is also saved, right, so those are the things that we have seen, right, so there also you can find the use of information communication technology. Okay, or in everywhere platform that ICT, okay, is used for these improved health services. Okay, next come the mobile health. Okay, or AM health. Okay, so which is nothing but that mobile devices like our smartphone. Okay, so that our daily basis that we use. Okay, so that is used for the healthcare applications. Okay, because you may surprise, right, so our each and every home, right, we have at least one smartphone, right, and now this smartphone, it is not only for conversation purpose. Okay, or it is not only for sharing the message or WhatsApp purpose. Okay, so it has having lots of inbuilt sensors. Okay, so those sensors are used for the healthcare applications. Okay, like many of us also do, right? Like what is my calorie burn? Okay, so there is a certain app is also there. Okay, we hold our phone and we check that what is my calorie burn, what is my calorie intake, and what is my calorie burn. Okay, from there I can see what is my health, the nutrition or the uh, that obesity point of view. Okay, what is my health condition, that I can monitor it. Okay, so the fundamental technology behind that is that it uses this the accelerometer, which is there inside this smartphone. Okay, so those accelerometer is used to measure that what is the total the distance that you have covered, right? And from there it calculate that what is your caloric burn, okay, using some predefined algorithms. Okay, so like this is one of the examples. I'll show few more examples when it will come to that the particular example of these the smart healthcares. Okay, so now this AM health or mobile health is also becoming the more the prominent. Okay, with the advancement of integration of too many sensor in our the daily used smartphone. Okay, and availability of that smartphone, availability means I'm talking about the cost. Okay, and uses. Okay, all the aspect I'm talking. Okay, so next after that it came the connected health. Okay, so which came in the vision of this smart city or smart village
Sir,
point of view. Yes,
sorry to interrupt, but only first slide is presenting. You're presenting only first slide.
is it?
Yes, sir. Please check.
I mean slide number 6. I don't know. Okay,
No.
let me unshare and then again share. Can you see my screen
Yes, sir. Now sixth slide is visible, sir.
now? It's moving the slides.
No, sir. It's not.
I don't know why it is happening. I am changing my slide, that is not coming at your end.
No, sir. Still, it's sixth slide only visible.
uh, what may be the reason for this? Is it happening for all the other participant also?
Yes, the
Hello.
participants are writing in the chat box.
Okay. Mm, but okay, let me do one thing. I'll just can you give me 1 minute? So I'll just quickly convert to PDF, and I'll see whether that will work perfect or not.
Yeah, sure, sir.
Hello. Can you?
Yes, sir.
Uh,
Your screen is visible.
yes. So let me. So now is it coming?
Yes, sir. Now it's good.
It's good, right?
Yes.
Okay. Okay. So maybe if people are not able to see this slide, so I just quickly move on that slide. Okay, so here I mentioned the outline. Okay, so then here I mentioned about that the traditional healthcare slide. What are the characteristics? So there I emphasize that traditional healthcare is resource constant, hospital centric, and reactive in natures, right? Then it came telemedicine, right, or the teleconsultation. After that, it came the e-health, which is nothing but the electronic health. The example is that electronic health record systems in hospital situations. Okay, so after that, I just discussing about this m-health or the mobile health. Okay, the how these mobile devices are used for the healthcare applications. Okay, so I hope there is no issue on the slides, right? Okay, so next is the connected health. Okay, so the connected health, it comes as I mentioned with the hand holding of this smart city or smart village with that context. Okay, where now this respective as you mentioned in the traditional healthcare, right, there is a lots of stakeholders are involved, right? So in connected health, so they connected those different stock holders. Okay, like that your the hospitals is connected with your the pharmacist. Okay, hospitals is connected with your the pathological lab, right? Then the drug supply chain, right? And obviously your patient, some of the doctors are also connected in this mode. Okay, so that's why you'll find this all those the stakeholders, okay, in this healthcare, they are connected to each others. Okay, even the academics or the universities also connected through this. Okay, because we academician, we also play a major role in the advancement of this the uh, the healthcare solutions. Okay, so by combining all those things, right, we have this smart healthcare, okay, which is came with the technology that IOMT. Okay, so where you see the doctors, nurse, the hospitals, even the your emergency services like ambulance, right? Everything is connected in one single platform. Okay, so just give me an example that of how this what is the role of connecting this ambulance in this IOMT platform. Okay, see, for example, whenever a patient is transferred from let's take a from a very remote location to the district the or the city hospitals. Okay, maybe that distance that the ambulance is covering maybe nearly 150 kilometers. Okay, so now within that 150 kilometers, right, so there is a, if I consider, there is a some referring doctors and there is some referred doctors. Okay, now in between when that ambulance is coming, right, so it is required to know that what is the health condition of that particular patient. Okay, and if required, there should be some emergency service, emergency medication or some that action need to be taken care. Okay, for example, what kind of action? Let's again assume that the situation, for example, that suppose that the the referred why it is going to come in the city hospital. Okay, it may find that it is still it is a 50 to 60 kilometer to be covered. Okay, but within the meantime that you find that patient health deteriorates in a different case. Okay, so you can't wait that much time. Okay, so then it need to be automatically, it requires automatically need to find the nearest the hospitals where you have that emergency services and automatically pre-book means book a seat for that. Okay, so that you no need to go there wait for that much far distance. Okay, and you can save the life. Okay, so this in this way, this entire connection from end to end, means from your referred remote place to the your city or in between the other the hospitals, and along with that your mobile ambulance. Okay, everybody should be in the on common platform. Okay, so then only that the services we can provide. Okay, so there actually plays the role of this IoT. Okay, now, through this IMT, what we want to provide, we want to provide the quality and sustainable healthcare with a limited resource. Okay, so this is a fundamental things. Okay, the basic requirement that why we are using for this IMT. Okay, Internet of Medical Things, why we are going to use it. Okay, so that we can increase the quality of services, we can make more sustainable healthcare, and with the limited resources. Okay, because you can't do that much the invest on the resource, the healthcare resource point, especially in country like India. Okay, so we have to use the technology, okay, within which may be used or enable to use only with the limited resources. Okay, so with that smart healthcare, okay, so there is a different technology, different the devices also came into the pictures, like fitness trackers, right? Then headband embedded with the neurosensors, okay, implantable wearable medical devices, okay, skin embedded the patches, right? So all are different new kind of technology also evolved. Okay, so it is, you can see this wearable medical devices means wearable electronics. Okay, wearable medical electronics is new domain came up. Okay, then this skin patches, right, embedded with that the electronics. Okay, so this comes that again screen means skin printed. Okay, so or like the tattoo electronics, those kind of electronics also came into the pictures. Okay, with the hand holding of these smart healthcares. Okay, so wearable technology is one of the fundamental things. Okay, so that is also now is on boom. Okay, in context with the smart healthcare. Okay, I'll later I'll discuss about certain technology of this wearable the healthcares. Okay, wearable technology point of view. Okay, some solution that what we worked. Okay, I'll just give an example of that. Okay, but before that, if I want to summarize what is the smart healthcares, okay, it is nothing but addition on that what is existing conventional healthcares. Okay, so on that conventional healthcares, you're adding the different kind of body sensors, smart technologies, information communication technology. Okay, then the AIML. Okay, so um, this power component, okay, is making that conventional healthcares toward the smart healthcares. Okay, and then the smart healthcares are the synonymous word that also we use very often, that is the Internet of Medical Thing or Internet of Health Things or this healthcare cyber physical system. Okay, that or HCPS. Okay, healthcare cyber physical systems means again comes with the again with IOMT, because now that all the patient information, right, all the health records, everything is available on your the cyber world. Okay, because the moment you're sensing that different physical parameters using this IoT technology, right? So that means all those physical parameters is now you're pushing to your cloud. Okay, so that means all the health status of that particular patient, okay, is available on the cyber world. Okay, which you can access from anywhere, any place, right? So that is actually making this healthcare also the cyber physical system point of view. Okay, the healthcare cyber physical systems is also sometimes is used as a synonymous of these smart healthcares. Okay, so yes, so this is the example of this healthcare CPS impact. Okay, you can understand. Okay, here the patient and doctors. Okay, so they are now they can talk to each others. Okay, so through these whatever things that we are able to achieve. Okay, so the patient specific care we can get it. okay, with context and embedded through the past health records. Okay, so you can get more patient specific or the personal health care, you can get it. Okay, and on the other, doctors, okay, doctors can do the real-time tracking and intervention, okay, which is missing in the traditional healthcare. Okay, that is enabling. Next, that it improved the inter-devices communication and the synchronization. Okay, and healthcare is now becoming a data-driven healthcare. Okay, so that means you have the patient all the health records. Okay, now from there you can predict. Okay, so when that particular surgery is required. Okay, if suppose my BP is increasing, so I may have some the cardiac issues. Okay, so then I should consult the cardiac consultant. Okay, so like this. Okay, so the healthcare is now becoming the data driven and also the predictive based. Okay, so actually this the prediction the predictive based healthcare is enabling the active mode of the healthcare services. Okay, because I mentioned the in traditional case we have a reactive mode. Okay, now this we need the active mode. Okay, means before the your severe issue or any that serious things happen, right? So your system should able to identify it and alert you well before. Okay, so that is a and give the respective the cares. Okay, so so that is nothing but that the active health cares. Okay, now this slide it shows about the healthcare characteristics. Okay, so in the smart healthcare characteristic point of view, it says it should have 7 P's. Okay, what are those 7 P's? The first one that we can easily understand, the participatory. Okay, means it should enable, okay, the defined the stakeholder to participate. Okay, next is the personalized. Okay, means it should the we can get the personalized healthcare, so it should enable that. Okay, perpetuals means if you want to own it. Okay, because this is customized totally for you and you can own it. Okay, so the perpetual things is also possible. Next is that the predictive, okay, data from the past historical data. It should be the predictive mode of the diagnosis and the treatment. Okay, then the preventative. Okay, it should prevent the severe or the critical health conditions. Okay, then programmable. Okay, means the with time the tech means whatever the solution that you are getting, right, it you can change it. Okay, it is not a hard coded. Okay, you can change your program, you can change your update your algorithm. Okay, newer version of algorithm you are able to get the update, right? So that's the point. Okay, programmable and pervasive. Okay, so when you called when you have this all major component, okay, that 7 P's. Okay, so then we can say that yes, that healthcare the hardware solution that we're developing, okay, it is a smart healthcare, right? Now, with that, if you see that a smart healthcare paradigm point of view, okay, so you have a healthy living, okay, where you are using like the fitness tracking, disease prevention, the food monitoring, sleep monitoring, right? So, healthy living point of view. Then, in home care point of view, you have a mobile health, telemedicine, self management, assisted living, and then the acute care, which is mainly the hospital centric. Okay, where the hospital, especially clinic, nursing home, community hospital, right, everything's where we are talking, right? So in a smart health case, it is not only your patient or the hospitals or the doctors, right? So now we are covering, we are talking about all, right? Which is starting from the what is your living style, right? What kind of food you are taking, right? So whether you are under stress or not, whether what is your sleep pattern, right, everything is important to monitor. Okay, so and then we have seen, right, how this home care is becoming much more dominant or useful in today's time. Okay, so like all of our house we have like SpO2, blood pressure measurement, the weight measurement, right? All this facility we have it. Okay, so now thing is that only thing is that we need to do it. We need to integrate everything in a one single platform. Okay, so that suppose if I suddenly got ill, right, and if hospitalized, right, so and if no one is there to explain what is my previous history, what is my last 1 month the health condition, right? So then the doctors should able to identify uh, from that platform, okay, what is my health condition, okay, in the last 1 month. Okay, so from there he can do the better diagnosis and the treatment. Okay, so that is actually enabling or enabled through this the IoT solution. Okay, so with this, the task that we are going to achieve through this smart healthcare, okay, so that as I mentioned, the daily diagnosis, okay, so where this wearable medical sensor is plays a major role, right? Then the daily prevention, like the fitness checkup, activity tracking, emotion analysis, okay, disease risk prevention, okay, and daily treatment, like the outpatient therapy, ambient healthcare, okay, disease status monitoring, okay, and even the precision medicine. Okay, so how much medicine you should take, right? All those things you are going to talk, okay, or it is going to solve the solution. Okay, then on the other hand, you have a clinical healthcare, okay, which is hospital centric. Okay, so where the physician and the personalized diagnosis is we are talking, okay, is taken care, and clinical treatment. Okay, so it is not only these two verticals are separate. Okay, so they are also having the cross relation. Okay, so the we are means 360-degree we are covering. Okay, using this smart healthcare or IoT technology. Okay, next, if you see the component of these smart healthcares, okay, so where the obviously that human or the patient is the first component, okay, and then on that patient body you are connecting different kind of wearable sensors, okay, wearable biosensors, I can say. Okay, so then those sensors is from there you are using this IoT technology, right? So you are bringing that data to in some data bank. Okay, so that means you can say that biobank you have, right? So after that there's biobank. Okay, so your that health cloud, you can say the is theirs. Okay, so now this cloud, from there you can access to EHR. Okay, means offline data purpose, means in hospital situations, or if you want to access the data, that is also possible. If the doctors want to access the data, that is present, right? So you can see that the component wise, okay, it is nothing but a collection of medical sensors, okay, devices, the healthcare database, and application that connected through the internet. Okay, so those are the major component of the smart healthcares. Okay, so this architecture point of view, if you see, generally we have a 4 layer of architectures, okay, where the first where all the sensor is connected. Okay, so there you are the body area network that you are developing. Okay, so defined kind of sensors is placed based on your requirement, right? And most of the cases these are the wearable sensors. Okay, and that sensors sense measure the data and communicate to the next. Okay, so now in between you have a layer 2, okay, for the communication purpose. Okay, so where your user interaction interface also is say. Okay, so because before cloud, okay, so this acts as a your gateway. Okay, because you have a several sensors is connected, right? So that you're going to send the data. Okay, so this may be your home care application or in the hospital centric application. In hospital centric application, that in you'll find one gateway may covering nearly 20 to 30 patient. Okay, in home care application, maybe one gateway is covering that maybe 4 to 5 persons the health status. Okay, so that's the role of this layer 2. Okay, and now this is smartphone, okay, or laptops, that also we are using the alternate of this the traditional gateway. Okay, now after that what you're doing, you got all of your data, right? Your data is out on your cloud. Okay, so then the data analysis is the integral part. Okay, it is not only sensing the data, you have to interpret the data, right? So that is also come under the umbrella of the IoT. Okay, so now there it comes under layer 3. Okay, so now here you see I didn't specifically mention that whether it is cloud or whether it is on the gateway where this the analysis you are doing. Okay, so because in healthcare point of view, okay, so the your analysis you may do in defined level. Okay, like you may do some cases on your the end device end. Okay, you may do your computation or analysis at your edge. Okay, or maybe your gateway. You may do your analysis on your fog layer. Okay, or you can also obviously you can do at your cloud. Okay, so accordingly we have a the four level of the four types of the data analysis techniques. Okay, like your cloud computing, fog computing, edge computing, and in device computing. Okay, so or on device computing. Okay, so those all four is possible. Okay, so that's why while you are doing, according your layer may be little bit change. Okay, and then at the end the layer 4 is that you are getting access of all the after that analysis that the result or the report. Okay, so that you are going to get it access. Okay, maybe your physician, maybe the the patient family members, or even sometimes immediate some other emergency services also so automatically takes care, like the booking of your the hospital bed, calling a ambulance for to take you from your home to hospital, just all those things is taken care. Okay, so this actually talks about the overall architectures of these smart healthcares or the IoT based healthcares. Okay, now in context with this IoT, okay, it is not only the measured sensor. Okay, the crowd sourcing is also used. Okay, so that crowd source data is also playing a major role, okay, in this the smart healthcare. Okay, and especially in the smart city context it is much more prominent. Okay. Now come to that, as I mentioned, the first things in your layer 1 you have defined kind of sensor you are connecting. Okay, so you know that from head to toe, right, you have in market lots of sensors available. Okay, and majority of the sensors now it is a very robust and precise. Okay, means so you can use it. Okay, and you can develop your own solution. Okay, you just see start from the headband, okay, which is used for your capturing your brain activity or EEG. Okay, so then the earphone that you're using, so it is also having different kind of sensors. Okay, because you may know that earphone, right, yeah, that now currently most of us are using, right, you have a mic, right? So the mic is again the it takes that the ear our the acoustic pressure, right, and convert to electrical signals. Okay, so these we can use for different applications. Okay, maybe you might have seen, right, certain case, right, for example, it can measure that what is my breathing pattern, right, because if I put my that mic near to my nose, right, my inhale exhale pattern I can measure it, I can analyze it. Okay, if I may suppose whether I'm swallowing or not, means whether I'm drinking what kind of food. Okay, so that also I can measure, because if this mic, if I put near my throat, okay, so when we drink, right, it creates some kind of sound. Okay, so it can also measure that what is your dehydration level. Okay, and it can also alert you, right, that in a particular time interval you should take a you should drink water. Okay, so like different use case we can develop, okay, using those solution that we are using. Okay, then you have a heart patch, okay, which is measuring your the heartbeat, your ECG. Okay, underarm patch, okay, that is used majorly to analyze your sweat. Okay, because sweat is also used to measure very different kind of health information. Okay, I'll show one of the example of that in later slide. Okay, so then it comes a T-shirt. Okay, so T-shirt is coming with the introduction of this textile electronics. Okay, this is another technology which is also coming with these smart healthcares. Okay, where that the electronics, okay, is embedded with that the whatever the T-shirt or the shirt that you are wearing. Okay, so it is embedded there. Okay, so like here one of the example here you can see, right, so this is the normal the thread. Okay, so in between it put, if you put a the metal coated wires, okay, metal coated the thread. Okay, so then you can make the connection. Okay, and you can and using that you can again make that electronics. Okay, so with this the several solution is also theirs, okay, in market or in academic research publication point of view. Okay, then you have this fingerprint, right? Now all of us are quite familiar with this SpO2 sensor. Okay, so then insole means what is my pressure that I'm impacting on my the sole, right? So insole sensors. Okay, because insole sensors is very much useful to know my gait pattern. Okay, gait patterns is used to analyze that if I have any kind of the arthritis or the orthopedic issue, okay, on my leg. Okay, so it is used to measure that. Okay, so from this you can understand that several sensors is there. Okay, people are using whatever the daily the electronics that you're using. Okay, people are using those electronics for our measuring our health information in different way. Just now as I give an example that how this normal earphone you can use for monitor that whether you're drinking water or not, or what is your breathing rate, all those things. Okay, you may not require to connect any other additional sensors. Okay, uh, and along with these people actively researching to develop new kind of sensors, okay, to get more accurate or more the critical parameter values. Okay, so these are the certain example that I'm just now mentioning about this textile electronics. Okay, the fabric electronics as I mentioned. Okay, so these are the certain the capacitor things that you can see. Okay, which is made of your no, sorry, these are the certain normal electrode patterns. Okay, it is made of this the fabric. Okay, and these are other electronics component, okay, which is used. Okay, so people are utilizing this, right? And with this what you can see that IoT is actually enables the us the future the visionary kind of ICU bed. Okay, so where you will have, it is, you can see the conventional ICU bed already we have. Okay, the different physiological signal, electronic health record, okay, the questionnaires, okay, all those things is there. Okay, so along with what is a new addition is this pervasive, okay, pervasive sensing. Okay, so it is merged. Okay, and then together it is giving the solution like the pervasive the patient information and pervasive environmental information. Okay, so why this patient and environment both the thing is required? Because you see the one of the example, right? The patient is lying on your that ICU bed, right? So what is the orientation of lying? Okay, whether the patient is when suppose he's coming out from that bed or trying to sit on the bed, whether he or she fall down or not. Okay, so those all those things is also important to monitor. Okay, in smart the hospital point of view. Okay, so there people using like accelerometer to measure that the patient movement, hand movement, the whether any accidental fall or any other anomaly is there or not. Okay, so all those things we can do it. Okay, so and along with you can also see this tele consultation is also becoming part of that. Okay, so this is actually one of the futuristic ICU bed. Okay, maybe in a very soon we'll have all those things in smart hospitals. Okay, so these are actually the first part. We have introduced that what is a smart healthcare. Okay, how it evolved, right? And what are the basic characteristic and features of these smart healthcares. Okay, so along with the role of the different sensors, okay, how it is used, okay, so that we have seen. Okay, so the next section I'll just talk about that how to build up an IoT solution. Okay, so it is most more about that if you want to build up a solution from the scratch, how you should try to do it. Okay, so these I follow the normal the IoT flow diagrams. Okay, so these I'm not discussing because this may already covered in your day one some of lectures might be right, because but I want to emphasize that the first thing that you require the IoT devices, okay, or the first thing that we call it is a IoT sensor node. Okay, so then you have a IoT gateway, then multiple the sensor node here or the gateway are connecting. Okay, you're making some kind of networks, maybe star mesh, whatever the topology that you are forming, right? And then that data you are bringing to the cloud, and finally from the cloud you are accessing, okay, means the information. Okay, so mainly it has the 5 layer of design. Okay, means the we have to build up. Okay, so I'll not talk about that much in this site. Okay, maybe the network, what kind of network you are going to develop, okay, or the gateway, it's so that maybe it is already covered or will cover in some other discussion. So majorly will focus here. Okay, because this is the first thing that we need to develop, right? So if you see this, as I mentioned, this is nothing but your the sensor node. Okay, and in the sensor node architecture point of view, you see, okay, what are the major component you have. Okay, first thing is your controllers. Okay, and there you are connecting means which is actually control different kind of sensors. Okay, sometimes you are also putting some kind of actuators. Okay, and then you have the sense data. Okay, is need to be communicated to the gateway. Okay, so for that you have a communication devices. Okay, and maybe while sensing you have to locally save, or maybe you are locally you need to process some things before communicating. So for that you require some kind of memory location, so you have some memory devices. Okay, and another important component is your power supply. Okay, because those sensor or controller or communication device, it requires the external power supply. Okay, so these actually constitute the basic building block of your sensor node, means hardware point of view if I am talking. Okay, so say means the design point of view. Okay, further in detail you can see here. Okay, you have a defined kind of sensors. Okay, that body sensor, temperature sensor you are connecting, right? And then those sensors is interfaced with your the controllers. Okay, now the important thing is here, some of the sensors is in analog, some of the sensors in digital form. Okay, so how you are addressing those sensor while communicating or interfacing with your controllers. Okay, because you know the controller only understand, microcontroller only understand your digital version, right? So if you are connecting any analog signals, okay, or if it is a generating some kind of analog signal, right, your sense data. for example ECG signal, it is an analog form, right? So then how will interface it? Okay, so that is one of the question need to be addressed. Okay, next the communication module point of view, as I mentioned. Okay, so you have communication module. Okay, now the power management part I mentioned, so the power management unit also be there. Okay, so I'll just discuss what is the role of power management in a subsequent slides. Okay, and the security. Okay, because as you are dealing with the healthcare data, right, so the data need to be encrypted, and we need to take the ensure the security issues also. Okay, so very often we put that the low weight some security protocols, okay, on our sensor node. Okay, so now coming to the security point of view, it is not only data security, device security is also important. Okay, because your hardware device might also be hacked. Okay, so and as you deal with the healthcare, okay, you have to give the foolproof solution. Okay, so you have to be secured both your hardware device and your data. Okay, so those things also part of your sensor node, right? So in sensor node design point of view, again we need to take care certain points, right? The first thing that you need to answer, you should have the answer, right? What are the physical signals that need to be measured? Okay, so because based on that you have to identify the correct sensors. Okay, next, how frequent we need to collect the signals, and how fast the data should be exchanged over the networks. Okay, because accordingly you have to write your programs. Okay, so now that the what is the frequency level of the collect signals. Okay, so why that is important? Because see, if I dealing a cardiac patient, right, so then my concern will be that the real time, almost real time monitoring of my the ECG and heartbeat. Okay, I may skip theirs, or I can do little bit relaxation on my the normal body temperatures. Okay, so that is a point. Okay, so when the moment you identify what physical signal you are going to measure, then you need to come up the what will be the collect means the sampling rate of that. Okay, and how fast your the data need to be exchanged. Okay, how fast means whether you are going to send the data immediately or in a particular time interval you can send. Okay, so that depends application to application. Okay, next is whether the sensor to be connected directly to the cloud or via the gateway devices. Okay, that also need to be find out, because accordingly your design will change. Okay, and last point here is mentioned that how much memory is required. Okay, because accordingly you have to give provision of the hardware, the memory. Okay, because see, if you are doing what is as I mentioned here, okay, we may do some kind of pre-processing at the initial level. Okay, so what is the sensor data, right, that you're handling, what is the size, that is important. Then the initial pre-processing the algorithm, again what is the size, that is important. Then you are deploying some kind of data encryption and the security protocols, right? Again for that you require the memory. Okay, so altogether so what will be the total memory requirement, that also you have to calculate. Okay, before designing the your the IOMT solution. Okay, now the sensor point of view, as I mentioned, okay, we have to take care about that the whether the sensor that you are connected, whether it is analog or digital. Okay, because accordingly you may require some kind of interface in between the sensor and your microcontroller. Okay, and also that the data type, whether it is a scalar or the vectors. Okay, because that is also important to know, right? Now, when you will identify, yes, this is a physical component I am going to measure, right? So then you may have a the n number of, again n number of sensor available to measure that particular physical component, right? So out of that, or in other way I can say you have a in market defined manufacturers is also available. Okay, so which sensor you should select. Okay, so the sensor selection is also important factors. Okay, so here's actually we talk about in sensor instrumentation point of view. So that is a performance characteristics, okay, of the sensor that you have to match with your requirement. Okay, so there first thing that you have to check your range, your accuracy. Okay, so what is the accuracy level that you are going to get using that sensors. Then the what is the precisions. Okay, so accuracy and precision, maybe you people know it. Okay, accuracy is nothing but suppose how close your the measured value with your actual the true value. Okay, and precision is that each and every times when you are measuring, right, whether most of the cases you are getting the same value or not. Okay, so that is your precision. Okay, then what is your resolution, fine. Then repeatability and reproducibility, your sensitivity, your selectivity, linearity and hysteresis, right? All those things you have to check, okay, while selecting your particular sensors. Okay. Next, as I mentioned, that based on your the sensor output, okay, you may require some kind of interfacing circuit. So, for example, if your sensor output is analog form, okay, which your microcontroller can't process it, okay, so then you have to connect the ADC, okay, analog to digital converters. Okay, now many cases the what is a microcontroller that we are using, so it has inbuilt ADC. Okay, for example, if you take the Arduino as an example, okay, Arduino board we very often use as a low cost that microcontroller at sensor node site. Okay, so then that Arduino board itself having some analog input pin, right? So that means on those input pins you have inbuilt ADC. Okay, but wherever if you change your microcontroller, if you shift from Arduino to Raspberry Pi, okay, so then you'll find a Raspberry Pi you don't have any kind of analog pins. Okay, so that means Raspberry Pi only can take the digital. Okay, but as I mentioned, you have your analog signals like your ECG. Okay, so then that need to be converted. Okay, so then additionally you need to put some kind of ADC IC chip. Okay, next the other interfacing is also in electrical point of view. Okay, maybe many of you know, right, that impedance matching is important. Okay, suppose it is giving the signal in voltage form or current form, you want to convert in vice versa. Okay, all those things is also required. Okay, case to case, right? So you need to select the proper that interfacing circuit. Okay, so then the comes the your microcontrollers. Okay, so where you are putting your algorithm. Okay, so the microcontroller should support to deploy that algorithm and run that algorithms. Okay, for example, if I consider that okay, I want to process initially some data captured by a camera on my Arduino, okay, which my Arduino might not able to support. Okay, so then I have to go for Raspberry Pi, okay, which can support. Okay, so that is also important things to select your microcontrollers. Okay, then security point of view I have already mentioned. Okay, and last point is a power consumption. Okay, so what is the power consumption of microcontroller, that is also important. Okay, because here we are going to use the low power microcontrollers. Okay, so that you can extend your device lifetime. Okay, then the communication interface, okay, we have to select based on your developed solution. Okay, the communication interface like NB IoT, LoRa, the 4G, LTE. Okay, all this communication interface is nowadays is coming. Okay, like if you want to make your own personalized network, like so they are the, and that also wide area network if you want to develop. Okay, your personalized own networks, so there this LoRa is coming. Okay, um, uh, and other technologies like simple Wi-Fi is already there. Okay, so those are the communication respective devices in you have to connect. Okay, after that it comes at power management. Okay, now when we are designing any sensor node, okay, so then many times, okay, so, because of sensor node that as a user I am wiring, right, so then I should not think that okay, every day I have to change my battery or I have to charge it. Okay, so it should last. If means in very remote case point of view, it should last for several means at least 1 year or several months. Okay, so last means that it should have the battery powers. Okay, so the power management, that's why it is a very much important. Okay, so I'll just little bit discuss about the power management point of view, okay, after this slide. Okay, but before that I am to show that the all those point that I mentioned. Okay, so with this the examples, okay, where you can see this the it is a hospital scenario. Okay, so where the this is one of the sensor node. Okay, so where you have it is a different sensor couplers is there. Okay, sensor coupler role is that if it is analog, then it is converting to digital and then it is accessed. And if it is a some other kind of conversion or the biasing, everything is required, or magnification amplification is required. Okay, so that is done in the sensor coupler point part. Okay, then you have a sensor controllers. Okay, and connecting devices. Okay, so there's one node is here. Okay, so now in this node, what are the sensor I have connected? You see the body position sensors. Okay, means some kind of accelerometers, ECG, the airflow sensor, EMG, body temperatures, blood pressure, glucose, galvanic sensor. So I have connected nearly that 5 plus 3. Okay, 8 sensors. Okay, so like this you have a node 1, node 2. Okay, like node n. Okay, so now all the node is communicating with your local gateway. Okay, and then that local gateway finally communicating to your cloud. Okay, and then the doctors may get access directly from your local gateway or your cloud. Okay, so that health information. Okay, so now I'll just emphasize certain points. Okay, so now if you see that analog sensor in this case, okay, I have connected so many sensors. So at first you need to segregate, okay, which is analog, which is digital. Okay, because accordingly you have to change your these sensor couplers. Okay, here you can see that analog sensor category, it come your temperature, galvanic skin, position detection, breathing sensor, ECG, EMG. Okay, now here again come you see the ECG and EMG. Okay, we can't process in the same times. Okay, because both are the periodic signals. Okay, then multiple channel of analog and digital embedded in the microcontrollers. Okay, this is one point. Okay, now come to the digital sensor point of view. You have a blood pressure, pulse, the SpO2, the glucose sensors. Okay, those comes as a digital sensors. Okay, but again if you can see the glucometer and blood pressures, okay, that also can be controlled. Okay, in the same time. Okay, so because they share the same serial link. Okay, so you need to change your program, okay, accordingly. Okay, so that means here you can't ECG and EMG you can't process in the same times, means there you have to do some kind of time synchronization. Okay, means time scheduling you have to make it. Here also glucose and blood pressure you can't measure and control simultaneously. Okay, so there also you can do some kind of again time scheduling. Okay, so those are the small things that you have to keep in mind. Okay, now other requirement point of view. Okay, so in this IoT node, okay, you have a physical constant like what is the size in, because as you are going to wire it, okay, the size need to be very compact. Okay, so on that point of view the term is a form factor is important. Okay, next the access of power. Okay, because here the what is the battery power. Okay, so that is available. Okay, that actually defines your the lifetime. Okay, means the battery energy and what is average the power it is consumed. Okay, power consumption point of view, as I mentioned, power is consumed during your sensing, during your communication and your initial pre-processing purpose. Okay, and from the sense and node point of view, okay, most of the power is consumed while the data communication. Okay, you can easily visualize, suppose if you connect your mobile phone to your data. Okay, means mobile data, and if you connect your phone, okay, next day to your Wi-Fi. Okay, you'll find when you're connecting your mobile data, right, your battery discharge rate is much more compared to your the Wi-Fi data. Okay, under the assumption that in both the days you are doing same kind of activities. Okay, means same kind of operation in your mobile phone. Okay, so that's from there you can understand the communication is takes care the majority of the power, okay, on your sensor node. Okay, so now on that context you have the concept of this active mode and the sleep mode. Okay, means whenever required that time only you measure and send the data, and other time you sleep. Okay, so that's the active and the sleep mode is there. Okay, and on that point again you have the trade-off. We have to do the trade-off, the computation and the communication. Okay, so that means whether I should send my entire, suppose 1 minute ECG data, or I should do some kind of pre-processing and only I'll send the final value. Okay, so we have to do the trade-off, okay, between the based on, again based on my requirement. Okay, and the cost and the security point of view, again that we have already mentioned. Okay, there should be some lightweight security protocol we have to deploy. Okay, these already I mentioned. Okay, so in that active mode and sleep mode. Okay, so the from power consumption point of view you have to take care. Okay, and handling of the data point of view, as I mentioned, the whether I should do the processing at the edge, okay, or the device level itself, or I should do on the cloud. Okay, so that the trade-off is also required to be done. Okay, so with this I now come to the third part of my talk. Okay, so before that let me ask if anybody have any queries, anything. Okay, so whatever we have discussed so far, you can discuss for 2 minutes. If you have any queries, I can address it. Hello.
Yes, sir, you are audible. If
Yeah,
anyone is
means
having any queries, you may put in the chat box, please.
okay, I can take a few questions or few queries so far, whatever we have discussed. After that, I'll come to this specific example. Okay, so I hope there is no queries so far. Okay, so let's then continue our discussion. Okay. Uh, So now in the third part is come that some specific example. So example point of view, I'll majorly focus at what about the work I did or we are doing. Okay. So here the first things I'll show that in healthcare scenario. Okay. So this is I have taken some example because as we are situated in the Chhattisgarh, right? So in the Chhattisgarh point of view, if you see, right, these are the some of the prevalent diseases. Okay, so that is not only Chhattisgarh, in the central India. Okay, so the first things you can see the anemia, then malnutrition, hypertension, the heart disease, cancer, right? Those are the things is there. Okay, so with this motivation, actually, we start working on this the anemia detection using this smart healthcare paradigm. Okay, so if you see there is the anemia screening point of view, okay, the globally the anemia it affects nearly 1.6 billion people. Okay, and in Chhattisgarh or in central India point of view, okay, so data says that nearly 43% of the young daughters and the mothers are suffering from the anemia. Okay, and most of them are the more prevalent one is that the iron deficiency anemia. Okay, so in general that existing techniques to address this iron deficiency anemia is invasive. Okay, means invasive means a complete blood count. Okay, CBC report. And you know that what is the cost of do a CBC report. Okay, varies from patholab to patholab, but in and around it takes nearly 150 to 300 rupees. Okay, so now you make these things that this most of these anemic patient you will find on the rural population. Okay, so um, for them it is not advisable, okay, to invest even that 150 rupees, okay, in daily basis. Okay, because you'll find most of these pregnant mothers, right, they require to check this their blood, the hemoglobin or the what is anemia status, right, in a regular basis. Okay, so that actually motivates us, okay, so in a non-invasive way, whether we can do this anemia testing or not. Okay, and before that the other motivation is that if it is invasive, okay, so still many of us are afraid to pick a blood up, means a drop of blood. Okay, or many times it is also people have a hindrance to come to or visit the pathological lab and give the blood and do the testing. Okay, so with that, actually the concept is that whether in a non-invasive way we can do the anemia testing or not. Okay, so with that motivation we developed this the smart anemia care. Okay, so this is a portable the smart anemia care which we name as a smo, smart hemoglobin meter. Okay, which we can measure the hemoglobin, and also from that we can predict what is whether the patient is anemic or non-anemic. Okay, so you see that that we claimed so this is a prototype hardware prototype device architectures. Okay, and from the we claim that it is a novel non-invasive method of blood hemoglobin measurement. Okay, it extract the how it be and what. Okay, it extract that the human eye conjunctiva, and from that eye conjunctiva it measures that the hemoglobin value. Okay, so how it is going to do, I'll just explain with this the slide. Okay, so we just captured the image of that human eye, including the conjunctiva part. Conjunctiva part means the lower part of my eyes. Okay, now after that we made a fully automated techniques, okay, to the crop or the get the region of interest, which is nothing but my simple that the conjunctiva. Okay, maybe many of us we know, right, we have seen, right, doctors in or at home. Okay, they check that by conjunctiva, right, whether it is reddish, whether it is whitish or not. Okay, from the that is a initial level of the anemia screening. Okay, so that we do. Okay, so we did this, we took the same approach but we made it fully automated, okay, using this solution. Okay, so what it did, okay, so from there it is a simple image processing steps. Okay, the eye detection, eye center detection, and then from there it finally detect the conjunctiva. Okay, so now entire process happened automatically. Okay, and with the keeping in mind that yes, finally we are going to deploy these things on some particular the micro uh, processor, means like a Raspberry Pi kind of things, or inside of our mobile phone app. Okay, as a app form. Okay, so means entire the algorithm or processing should be very much lightweighted. Okay, so that is the underlying constant. Okay, so that we kept, and then from there we calculated the histogram, and then from there we measured that what is a hemoglobin value. Okay, so based on that hemoglobin value it has decided whether anemic or non-anemic. Okay, so these are the process steps that is followed in this solution. Okay, and you can see these are the certain study, okay, in our preliminary study. From there that how the left and the right eye, okay, it is correlated with the actual hemoglobin value. Yes, you can see it is a good correlation it's showing with the actual hemoglobin, means actual CBC report, with the developed solution. Okay, so later, some of the other information is also embedded, like the geospatial information. Okay, so with the vision, suppose if the solution is used for some of the health workers, right, in a village. Okay, so then that will get from this, right. The suppose they will do the home. that every home that they'll visit and they'll do this testing. Okay, so then from there we'll get that exact the footprint of that the hemoglobin or the anemic patient on that particular village. Okay, so this actually will help if we, when we'll integrate with the government agencies or the government hospitals, right? So so this will enable, right, where the severe anemic patient is there, okay, where the mild anemic patient is there, and if the severe anemic patient means they need to have the continuous support and the monitoring, okay, of their health status. Okay, so so with that we have embedded this geospatial information, and along with some of this iron deficiency anemia is directly related with their food habit and some of their other diseases. Okay, so so that also enables us to understand that what kind of things is there. So this work is under going. Okay, so this part we haven't done. So this is because after development of this solution, okay, we brought in a mobile phone point of view, okay, so as a mobile phone app. Okay, so now we are going to use more in field study, and we are going to get some more other inference, okay, from there. Okay, next, we use a similar concept to identify the blood glucose and the diabetic monitoring. Okay, we name that technology as a glucam. Okay, so you know this during this pandemic. Okay, so this entire healthcare system, okay, it shifted toward the active patient centric. Okay, as I mentioned, instead of reactive patient centric, it to be active patient centric. Okay, um, so now existing this glucose monitoring or the diabetic measuring techniques point of view, if we see that it is although there is some non-invasive methods are there, okay, but those non-invasive methods are suffer from the manual operation, okay, and it's reliable on the external gadget, okay, the it changes with the lighting condition, and overall the cost is also relatively high. Okay, so with this we again targeted to make a smartphone based, okay, means a mobile healthcare means mobile health based this glucose monitoring or diabetes sensing. Okay, so here the fundamentally what happens, so in this image you can see, right, the upper part of your eyes, right, so the blood vessels are there, right. So now if the blood diabetic level increases, okay, or the glucose level increases, so this tortosis, okay, this of this the blood vessel, okay, so means this curvature and bending of this blood vessel, okay, it changes. Okay, so we utilize this phenomena, okay, to measure that what is a glucose level, okay, from this captured eye image. Okay, so these again it shows that how this IoT will come in this way, okay, where as a user you can do test by yourself, okay, or as a health worker you can do test for the individual the patient, okay, using simply your mobile phone. Okay, so now then entire data is come to your central place, right, where your machine learning workflow is there. Okay, so we have also brought that machine learning algorithm toward the mobile phone end. Okay, so that means we targeted toward the edge based intelligent solution. Okay, but the entire information when it will be again in the centralized place in a cloud, right, and from there again the respective the physicians, the telecommunications, right, all this thing is possible. Okay, for example, how this telecommunication may use this solution, because whenever they are doing the teleconsultation, right, we are looking in front of the our webcam or our mobile phone camera. Okay, so then just simply place your camera, okay, enable that functionality of this glucose measurement, so doctors will instant get there itself what is a glucose level. Okay, doctors there it instant will get what is my hemoglobin level that we have discussed. Okay, with this we are enabling this the smart tele medicine or the teleconsultation services. Okay, so again, this shows the workflow of the glucom. So this also similar kind of approach. Okay, your input image like a simple eye image, but this time is highlighting to the upper part of your eye image, and then entirely again the automatically we extracted these vessels, which is our region of interest, and then from there geometrically we calculated this tortuosity. Okay, so and then based on the tortuosity there is a certain we trained our model um, uh, uh, using some machine learning algorithm, and then from there so we came to a threshold value. Okay, so that threshold value is again decide that that what is the whether the particular patient is diabetic or non-diabetic. Okay, and not only that we can also get the glucose values. Okay, so this shows the different samples, and then that how the left and right eye that tortuosity. Okay, so how it is related with your glucose value. Okay, here you can see. Okay, so nearly 1 point means 1.1 or 1.15. Okay, in this range. Okay, you can see that the little bit change of the tortoise value, right, means a reduction. Okay, so it drastically changes your blood glucose level. Okay, so the same thing for your the left eye also. Okay, so we develop this, and again we make it smartphone enabled. Okay, so this is from your eye image we can we have proved two solution. One is your the blood hemoglobin which is used for the anemia, and another is a blood glucose which is related to your the diabetic. Okay, next solution in Chhattisgarh point of view, maybe some of you recently have seen some news also came that leprosy is one of the active disease in Chhattisgarh. Okay, so we also worked on that point of view, the skin lesion diagnosis. Okay, so the severe case we consider as a the melanoma or skin melanoma. Okay, so again this is a architecture for the smart healthcare point of view, means cyber physical system point of view. Okay, our skinet cps system it works in this way. It required a camera and one attached that dermatoscopic camera. Okay, and your mobile phone. Okay, so every the primary health centers we are expecting if they are using this. Okay, so then through these doctors will simply take the image, okay, of that particular patient where you have that the skin lesion. Okay, and then that image will be uploaded. It will come to the center place. Okay, where the model is deployed, and then the trained model is already deployed. Okay, so that new image will come, and from there it will give the suggestion that what is the kind of that lesion, whether it is a the leprosy, whether it is a simple some kind of burning problem, or it has a, some kind of malignancy. Okay, so with that again we have developed two solution. Okay, I think it is not running here. This is a small embedded video that I kept. Okay, so this is that skin cancer. Okay, so we made in a two version. One is that web version. Here you simply uploaded image. Okay, you capture and upload image. Okay, you will get that whether it is malignant or not, and if it is malignant, which kind of malignant. Okay, and what is a stage. Okay, so that you can get it. And then we also brought this solution with the edge intelligent, means we the solution at the mobile phone itself, keeping in mind that the solution is used in some of the places where the network is not available. Okay, so the standalone solution. Okay, so the smartphone point of view. Okay, again you can see that entire the data processing, pre-processing, and the training. Okay, and the testing, everything's happen on the mobile phone itself. Okay, so that if you can if you capture your image, and from there so in the mobile phone itself you can get the uh, your recommendation, right? This is what disease and what kind of skin lesion is this, and what is the remedy for that, okay, or the treatment procedure is for that. Okay, so in that way it gives all those information. Okay, next is there is some solution again with respect to the covilan. Okay, so these again we emphasized the primary health centers. Okay, like some of the study enabled or proved that the X-ray device also is used for detection of this the COVID. Okay, so which might not be means the primary health center, we can't expect that they will have in the CT and all the other treatment facility. Okay, but we are expecting, suppose on X-ray machine is there, so with that we have vision that the X-ray machine or the future is X-ray machine that we are named as a smart X-ray machine, where the inbuilt machine learning model which will take care this the COVID the data. Okay, so so that we can get the immediate the solution. Okay, so this is again the schematics of that architecture. Okay, the CPS point of view, the X-ray that is installed at your primary health centers, right? And then from there it is coming it is communicating to the respective edges. Okay, so then the edge intelligent or the machine learning model is deployed at the edge. Okay, and then if means which is taking care of the initial level of the processing, and then finally it comes to the your cloud platform. Okay, and then at the end again you have a service layers. Okay, in service layer again defined the stakeholders is there, like your the COVID hospitals, right? Means if there's a person is identified, okay, means from your primary health center, it need to be transferred to the in nearest COVID hospitals. Okay, so and then online consultation should also be done. Okay, and if in a particular that the location you have a more number of the patient, okay, you need more the logistic support. Okay, that also it should take care, and the local administration information. Okay, all those things you can get access through this. Okay, so this shows the service layer all those functionalities. Okay, and this is the hardware architectures of these next generation these X-ray devices. Okay, where this the covalent module, right? This inter ML module is embedded. Okay, so I'm not going to the detail of that. If anybody interested, you can follow this link and you can go through the paper in details. Okay, so how these entire things works? Okay, the patient will come in front of the X-ray machine and take the image. Okay, so after there's automatically the data pre-processing, data augmentation, the and then the your the CNN networks. Okay, it takes care and it classify whether the data is COVID and the normal. Okay, so these are show some of the result of that. Okay, how to study. Okay, next, the another example, as I mentioned, that in healthcare point of view, the sweat, okay, in body area network point of view, the sweat, the underarm sensors, okay, the sweat is also plays an important role. Okay, because you see the sweat is readily available and in a non-invasive biofluid. Okay, and it contains different biomarker like your glucose, then the lactate. Okay, so which is used to detect various diseases. Okay, so and not only that, it also carried multiple electrolytes like the sodium, potassium, chloride. Okay, which can impact the conductivity of the fluid. Okay, so now for this we developed a the paper pen based device. Okay, so this is a paper. Okay, simple chromatographic papers. Okay, or a photo papers, on that we take the printout, and that on that, okay, we use some graphite means simple pen, no, pencil. Okay, the lead graphite. Okay, pencil, with that you make the electrode. Okay, and this outer boundary, this square boundary, okay, is nothing but a marker pen we used. Okay, so you know those marker pens. Okay, so they are hydrophobic in natures. Okay, so whenever you put a drop of sweat inside that, okay, so it should not, because in general the paper, you know, it has a lots of the capillaries. Okay, this is the schematic view of this the paper you can see. Okay, it has a lots of capillaries. Okay, so if you put a drop of sweat here, so that through this capillary the sweat or the solution it can come towards this. Okay, but we need to restrict it, and for the restriction or make a small micro reservoir, we use this the micro sorry, this marker pen. Okay, so this is a graphite electrode and this is the silver electrode. Okay, silver electrode means now it is you also find them some kind of the circuit describer is available. Okay, so to make that electrical, if there is some electrical discontinuity happen, right, using this those silver the pin, right. So the again the silver nanoparticle is there inside that ink, right. Using that we can joint that electrical connection on our PCB board or in our electronics board. Okay, so we use that pin. Okay, and using that we made that the electrode. Okay, so in between that we, if you put your sweat, then based on your that ions. Okay, so if you put the based on your availability of the ion, right, so they will come and put means it will fill in between those two electrodes. Okay, so when you are going to measure the impedance, okay, so then you'll find the impedance of this is reduced. Okay, so what I'm telling, when nothing is there, okay, no sweat is there, so what is the impedance, and when sweat including the ions is put inside this, okay, or over this electrode. Okay, so then overall impedance value changes. Okay, so now we use these principles to measure or to analyze the sweat. Okay, means what are uh, the the components, ionic composition, to measure that. Okay, so these are the, you see that these are marker pen. Okay, inside that how the respective part of that defined volume of liquid, if you dispense, right, how it will be concentrated. Okay, so and next these you can see that so it sample the different means change of this so it composition value. Okay, means how it is actually giving the different impedance value. Okay, so from this graph you can understand. Okay, so we use this again for analysis of the sweat. Okay, for detail you can again follow these papers. Okay, you can get the more detailed understanding of this. Okay, next the another example, so that is the aging fit. Okay, so which is we propose for the geriatric healthcare. Okay, so geriatric means elderly people or old age home, so those who are staying, right, for them we propose this solution. Okay, so you know the elderly people very often they fall down. Okay, so it requires that human activity tracker. Okay, so that means some kind of wearable sensors should always be attached with them. Okay, so that they we can monitor in a by sitting a centralized place, right, whether that particular person is fall down or not. Okay, and majorly you know that those elderly people they fall down, most of the cases you'll find inside the washroom, okay, or the bathroom, right. So and our means our practice is that you close the washroom, and then if some accidentally if someone fall down, right, it's very difficult to attend that. Okay, so we require some kind of the real time the activity tracker or fault detection mechanism. Okay, and along with it required that particular place should have some other normal the body temperatures, ECG, the blood pressures, which those the elderly people they suffer or they require very often the solution. Okay, so it the idea is that again architecture point of view. Okay, so it is everything is connected through the IoT platforms. Okay, and if there is some kind of anomaly appeared, so some immediately emergency alert will be given, and it will be informed to the nearest hospitals, or maybe if possible that family persons will be intimated. Okay, so this real-time health monitoring in accidental fall point of view. Okay, so just uh, excuse me because this it was embedded video on the PPT. Okay, so in the PDF it didn't come out. Okay, so this actually shows a although it is a very initial stage, okay, later we packaged it. Okay, so I just want to show all those different parts, okay, as I mentioned in IOMT architecture, sensor node architecture point of view. Okay, so that's why I am showing the bare one. This is your Arduino board, okay, and there your accelerometers is theirs, okay, and which is used to sense the activity of that. Okay, and then it is not only that, okay, many times we also embedded that smoke detections. Okay, so so that that whether because many of those people, they elderly people, they also suffer from that breathing issues. Okay, so what is that the environmental pollution, or the whether nearby any smoky environment is there or not, that also need to be monitored. Okay, so those things we integrated inside the solution. Okay, so um, I am not able to show this if time permits. Maybe if someone is interested, I can show you this trial video, okay, from my PPT. Okay, next solution that we have developed, so that is again the health assessment of the office workers. Okay, because nowadays you right, all of us is sitting in online mode and we are working, right? So so our lifestyle is totally changed, right? So our if you see our activity point of view, maybe nowadays 80% times we are sitting and working. Okay, so that sitting maybe at your is in front of your desktop, or in your sofa, or simply on your simple office desk. Okay, so then again the people are stressed. Okay, stress in both in physically and mentally. Okay, so that need to be monitored. Okay, so and some of the other things. Okay, so most of us now, office point of view, we are working under air conditioned environment. Okay, so we are not that much dehydrated, okay, from the body surface point of view. Okay, but internally our body requires the water. Okay, so so this actually getting that we are not drinking the adequate water. Okay, and also we are using excessive mobile phone. Okay, so and long term exposed to the computer screen is also making our eyes dry, right? So those are the other the health issues. Okay, so whether I can monitor my what is my the entire day activity, okay, means from my stress or my healthy lifestyle point of view while working. Okay, then I can resolve my bad habit. Okay, so this is again some of those solution. Okay, so which is used to measure that different activity, like whether they're drinking water or not, whether they're eating, then rubbing eyes. Okay, how frequently rubbing eyes means that may create impact on your eye due to the long-term exposures of your the laptop or desktop screen. Okay, so then you have a smoking habit or not, because if you are stressed, okay, many times we have a practice of this smoking. Okay, and also the talking of phone on phone, right? So different activity based again the monitoring solution we have developed. Okay, so this comes under the physical stress point of view and the same situations. Okay, because as I mentioned, so like if we ask okay, all of us are now sitting. Okay, so now the question comes, how many of are sitting in the right posture? Okay, whether my posture is correct or not. Okay, so because nowadays you find this back pain problem, okay, is becoming very common, okay, in our and that is actually due to the wrong sitting postures. Okay, so for that again we developed the wearable sensors. Okay, the inertial based sensors. The IMU is nothing but inertial measurement unit. Okay, so and from there, so we captured the defined postures. Okay, so whether your posture is right or wrong. If it is a wrong, if you're sitting for a wrong posture for a more time, so then automatically it generates some kind of alert. Okay, and next another point also we can do from there, like the what is your that back pain, means that uh, 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 that that your curvatures, okay, because if there is any severe the arthritis issues it happens, right? So you'll find that there is a from the x-ray, okay, you'll find that that it creates a bending, okay, so at your back spine, okay. So that also we can monitor, okay, that whether the any alteration or any change in that spine geometry is happening or not, okay, through these wearable sensors, okay. So that is another the work that we are working towards that, okay. So after this I'll just show another example, okay. So this is most about the, hello, okay. So this is about that in vivo blood flow measuring, okay. So you know that whenever we do any kind of the open heart surgery, right, we need to measure that inside that artery what is the blood flow, okay, because it also gives a different other kind of information, okay. So with this example I am to introduce what is the other use of these wearable sensors, okay, or the flexible sensor as I mentioned earlier, okay. So this is the things that inside the blood vessels, right? Generally, doctors inserted a catheter. Okay, inside the catheter that we have to place our sensors. Okay, and here we use the sensors is nothing but a water anemometers. Okay, you know that if we have a that heaters, okay, and if you put the heater on a flowing liquid, right? So those heat is dissipated, okay. So if the flow is in that direction, okay, in the same direction, so the flow that the flow while it is the liquid while it is passing through it takes away that the heat, okay, and then overall that heat changes means the heater resistance changes, okay. So by measuring the heater resistance, okay, so you can check that flow rate, means if the more flow means flow rate is more dissipation, more dissipation of, or absorption of the heat, okay. If less flow, absorption of the heat will be less, okay. So like this we can correlate these heater temperatures, okay, in the form of the change in resistance, okay, with respect to that what is a blood flow. So that is the principles, okay. But here the major challenge is that how will make the sensor and wrapped around that the catheter. Catheter is nothing but this kind of cylindrical shape, okay. And all further these things we are going to insert inside the body, okay. So these all those component need to be biocompatible first of all. Second, as it is coming in contact with the blood, so you need to uh, properly protect it, okay. So all those things is there, okay. So in this context normal silicon based technology, okay, we can't bend it, okay, because you know the silicon is brittle in uh, property, okay, it will break it, okay, we can bend it, okay. So there it comes at flexible electronics or this wearable flex, the implantable sensors, okay, in the smart healthcare technology, okay. The implantable sensor point of view, maybe the you know this insulin pump, okay. So that is a implantable sensors, okay. This is another example of this tattoo electronics, okay. This is very much interesting, right? The fetus heartbeat also you need to monitor, okay. So this is the another example that tattoo electronics how it is used for measure the fetus heartbeat, okay. But I'll just talk about the technology point of view, the flexible electronics, how it is used, okay. So in flexible means, as I mentioned, the normal silicon technology is not going to work, okay. So we have to use some kind of substrate, okay, which is flexible, and which is flexible means which you can bend over a the cylindrical tube, okay. So with that there is a comes a different kind of flexible materials, okay. So on those materials, one of the materials is the PDMS, okay. So which is biocompatible, okay. So that is also the first and foremost things is important in this case, okay. So the flexible technology having the different applications, okay, not only the biomedical healthcare. So in consumer electronics point of view, maybe some of you have it or you have seen that the Samsung the Edge, okay, or Samsung the skin is also now foldable, okay. Or Samsung Edge means you see the screen is in the edge side also you have a screen. Okay, so those are the example of this flexible or the bendable electronics, okay, which is not possible with our traditional silicon based technology. Okay, so here we used so this is during my PhD times some of this work. Okay, so we use these PDMS materials, their inherent technology, inherent characteristics to measure this the flexible whatever implantable solutions. Okay, so in nature, PDMS is a hydrophobic in nature. Hydrophobic means it will repel the water. Okay, so means it will repel the water means it will not allow any other material to uh, adhere. Okay, but you as you mentioned, we have to principle wise we have to make some kind of heater. Okay, because we use this PDMS as substrate, and on that substrate we have to use some kind of heaters. Okay, but the heater suppose it is made of some kind of chrome chrome alumel. Okay, so that or no sorry we use the nichrome material as a to build that heater. Okay, but that nichrome you can't deposit. Okay, because of this hydrophobicity. Okay, so first objective or first target is to reduce this hydrophobic nature to the hydrophilic. Okay, so the hydrophilic means simple contact angle point of view. Okay, if it is more than 90 degrees, so it is a hydrophobic. Okay, so just like you may have seen like your the lotus leaf, right? On that you will not find that water is not wetting the surface. Okay, so the if rainwater you might have seen that it is just simply making a drop and it is coming out. Okay, so that is the example of in nature's the natural the hydrophobic surface. Okay, so same thing here also it appears. Okay, so we have to make hydrophilic means this contact angle below 90 degree. Okay, but ideally we need to make it for practical use case application nearly 30. Okay, so then only you can do the this the nichrome deposition. Okay, so using some the treatment, okay, it is done. Okay, and then this is the treatment we used. I'm not going to the detail of this treatment or this technology. Okay, if anybody is interested, again you can visit and you can go through these papers. Okay, you will understand it. Okay, but the moment we try to deposit the nichrome, okay, so this is a PDM is a polymer, and then using the this deposition techniques. Okay, so these deposition techniques means it comes under the MEMS microfabrication technology. Okay, because as we are going to make a micro devices. Okay, so when it try to deposit, okay, so then either the thermal deposition or sputtering. Okay, so some techniques is there. Okay, let's forget about those techniques, but one thing we can understand here. So whenever we are depositing, okay, so it generates the heat. Okay, or the temperature increases. Okay, so due to the temperature increase, what happens, the the PDMS, which is a elastomer, it is thermally expanded, and also the nichrome material, which is also thermally expanded. Okay, but thing is that a nichrome material and then PDMS material thermal expansion is different. Okay, so due to the mismatch of this thermal expansion, what happens, so it generates some kind of random buckles. Okay, so the surface you will find this kind of buckles. Okay, so this is inherently it will generate. Okay, because these are material characteristics. Okay, the thermal mismatch of two material, it is a material characteristics. Okay, you can't avoid it. Okay, so now we use this although this is a demerit, but we use this demerit as a merit in our application. Okay, because now our what is the target, so now if I now stress it, okay, you see it is a elastomer polymer. If I stress it, okay, um, no, but before that, let me tell another thing. So the random buckles, okay, so now if I make these random buckles to an oriented buckles, means only one direction of buckles. Okay, one direction of buckles means, I'll just give an example here. It is yes. Okay, here you can see. Okay, it is one direction of buckle. Okay, you don't have the zigzag or horizontal buckle. You all the buckles in the vertically. Okay, now if we have that, okay, so then if we stress it, okay, so then these buckles is actually allowed to stress or bend your substrates towards that the catheter or the cylindrical tubes. Okay, so I'm not going to the detail of this entire fabrication steps, but here you see this is the some photograph of this, how on that catheter tip that sensor is enabled. Okay, so like this kind of defined technology is people are using for making this flexible or printable the sensors in the smart healthcare applications. Okay, so I thought this may be useful to discuss or to know that what is happening. Okay. Next, some other things, as I mentioned, that the skin based electronics or tattoo electronics, how it is coming into the pictures. Okay, how people are using for different applications. Okay, they are making different kind of electronic circuit. Okay, to sense the different physiological conditions. Okay. Now I'll come to the last portion of my talk, which is the smart healthcare, some of the challenges. Okay, so the first things you can understand that the user as a user is integral part of this entire Internet of Things or IoT solution. Okay, so the privacy is a first and foremost concern it comes. Okay, so it is not only the user privacy, user data privacy. Okay, and the device security is also important. Okay, and also the users the identity threat is also another concern, right? And next is that as the different people they are sharing their health information over that the platform. Okay, so you require the unique identification, which is again a challenging things. Okay, so this with respect to the users and the data. Okay, so these are the certain challenges. Okay, is there. Next is that the processing or the model point of view or the data point of view. Okay, you see the data quality point of view required, it should be reliable. Okay, the data should be the validated data. Okay, that it should be validated by medically. Okay, medical standard should maintain. Okay, and also the objectivity. Okay, means in which objective, in which purpose you have collected data. Okay, because it is not that accelerometer value I can use for my orientation purpose, I can also use for how much jogging I'm doing. Okay, or so but both the cases my data will different. Okay, so the means although my data type is same. Okay, but as my objective of my application is different, right? So my data quality will also different. Okay. Next is the completeness. Okay, whether the data is able to completely capture your that particular health information or not. Okay, so again these are the question or these are the issues that we have to address. Okay. Next is, as I mentioned, the machine learning is integral part of this solution. Okay, so but in normal case, you know that when you're dealing with that healthcare data, okay, it requires the high computational resource. Okay, and another thing is a class imbalance issue. Okay, class imbalance issue means your healthy class means data and your disease class data. Okay, there is a uh, most of the cases you will have more healthy class data compared to the disease or unhealthy condition. Okay, so that actually creates a class imbalance problem. Okay, so again how to address that class imbalance issue, that is a separate discussion, separate research scopes are there. Okay, next is large amount of data, as I mentioned, how we are going to handle it. Okay, the third point is a model that integrate the model into the application. Okay, so and the resource and the energy. Okay, so the moment you are integrate the model to your application, right? So whether you have a sufficient resource or not. Okay, as I mentioned, suppose you developed a deep learning model and you want to deploy it on your mobile phone. Okay, whether your mobile phone support that. Okay, even if it support, right, if it is consume lots of power, right, to run it. Okay, so then it may not work it. Okay, because you have to take care that all the other aspect, right, your available power resource. Okay, to run that particular model. Okay, so again those are the certain other concern. Okay, or the challenges that still open up. Okay. Next, although these I have earlier mentioned, okay, in a smart healthcare point of view, whether you should do the edge computing or cloud computing. Okay, so that also is another concern. Okay, because you see from the cloud computing, if you want to do, okay, you have a huge data, you'll get it. Okay, fine. Okay, you can build up your very robust machine learning model. Okay, but for that you require lots of computational resources. Okay, and then accurate data analytics is also required. And overall what you'll find, the latency in the networks. Okay, so as a latency in the network is there, so means in smart healthcare point of view, you might not have that much provision, okay, to have that latency. Okay, means when you are measuring and when you are after processing, when you are getting the result, right, you might not have that much provision in time. Okay, you may require very rapid the solution. Okay, so in that point of view, it comes a edge intelligence. Okay, but in edge intelligence having the other issues, like you have a less data, so the less computational resources required. Okay, less accurate data analytics, but here the advantage is that you will get the rapid response. Okay, and even you may require that one device. Okay, one device there and then itself the decision. Okay, so there obviously you will have the minimal data, but you will have a very rapid response. Okay, so based on your application, based on requirement, you have to do the trade-off and you have to select which kind of the intelligence mode that you are going to use for your particular case. Okay, so with this, I'll just conclude the overall talk with the following future directions, and the concluding or the take-home message is that healthcare has been evolving to the healthcare cyber physical system. Okay, from your traditional healthcare. Then Internet of Medical Things and AI play a key role in these smart healthcares. And smart healthcare can reduce the cost of the traditional healthcare and give more personalized experience to the individual. Okay. Now the challenge in the future direction point of view, this they still remains. Like although this I am to provide is advantage, but need more research in terms of the robust data, device, and that CPS security point of view. Okay, then machine learning models for the healthcare needs to be further researched. Okay, lightweight, all those things is essential. Okay, in and last is in a smart city or a smart village point of view, human as active part of the crowdsourcing data. So that is a crowdsourcing data is another research domain is also emerging in a smart healthcare paradigm. Okay. So with this, I thank all of you for kind attention. Now, if you have any questions, you can ask me.
Thank you so much, sir. That was such a wonderful session and presentation. We are very grateful to you, sir, for your precious time and kind words. I request the participants, if they are having any questions, please go ahead. You may put your questions in the chat box or on your mic and ask.
Thank you very much, sir.
Yes, thank you.
Yes, participants, if you have any questions, please.
नमस्कार सर, मैं पीयूष लोटिया बोल रहा हूँ जगदलपुर से।
Yes, namaskar.
सर, आपने जो बताया है वो बहुत बेहतरीन बताया है, बट राइट फ्रॉम द बिगिनिंग टू एंड आपने ये भी बताया है कि क्या क्या हो सकता है। बट सर, मैं अभी आपसे ये जानना चाहता हूँ कि ट्रिपल आईटी लैब में क्या क्या फैसिलिटीज है, और यदि हम अपने बच्चों को कुछ आईओटी मेडिकल बेसिस पे कुछ कराना चाहें एज प्रोजेक्ट या फिर मेजर प्रोजेक्ट या माइनर प्रोजेक्ट या किसी पीएचडी स्कॉलर को भेजे, तो वहाँ से आपके यहाँ से क्या क्या मदद मिल सकती है?
Okay. Means you're asking the facility point of view. Yes, we have.
मतलब इमीडिएटली हम अभी क्या काम स्टार्ट कर सकते हैं सर? आपने जो बताया दैट इज द स्कोप ऑफ मेडिकल आईओटी पूरा कंप्लीट।
Yes.
इमीडिएटली यदि आज से यदि मैं कुछ काम करना चाहूँ, कुछ प्रोजेक्ट लेना चाहूँ, कुछ बच्चों को प्रोजेक्ट लेना चाहूँ,
Yes.
तो क्या कर सकते हैं उसमें? अभी आपके यहाँ की लैब में क्या क्या फैसिलिटीज हैं, ये मैं जानना चाहता हूँ सर।
Yes. No.
My wife is also studying at the Institute for Information and Telecommunication Department in 3rd year. But अभी आपके यहाँ जो नई लैब बनी उसके मेरे को उसका ज़्यादा आइडिया नहीं है।
Okay. No. Our lab is I think it is quite developed. Okay, we have all the the variety of sensors, okay, even in the smart healthcare point of view. Okay, and not only that, different other kind of instrument is also there, okay, to do the other studies. Okay, so and along with the other computational services, okay, like workstation, everything's GPU workstation, everything's we have it. Okay, now yes, the research problem point of view, maybe you have seen the whatever the problem that I have discussed on that is some of them that I have shown here, which is published. Some of the things we can't show what you're doing now. So you'll find most of this is not only for academic research. Okay, we are making as a final kind of product, okay, or solution kind of a smartphone based. Okay, so currently we are means especially in our group we are more focusing on the rural healthcares. Okay, defined issues are there. Okay, so if you are interested to work on that, we are happy to help and collaborate.
Okay, sir. Thank you.
Yes, my mail ID is Debanjan. I'm just typing in the chat box. Yes, you can reach. Any other point to discuss? Okay, I do understand that means detailed technology point of view it may be difficult to cover in this time frame, but if you require to know about more, you can.
Some of our students are interested in work in medical IoT. That's why I'm asking this.
Yes,
Is
yes, means
there any
they
help
can.
from others?
You can connect later. Okay,
Okay.
maybe you can connect later. Yes.
Yes, Yogita madam, you want this?
Yeah. First of all, sir, it's a very nice and interactive session, rather interactive. This is more informative session. The likely, like many of the us are saying that are asking about the medical field, like if somebody is working with